Okay, it's the start of the chapter 2. We're talking about conditional statements. This is really the beginning of proofs here. Okay, so chapter 2, we can start introducing proofs. Now I know what you're thinking. All your friends in the grade above you or who took this class before, they think proofs are the worst thing in the world. Okay, proofs are not too bad. You just have to break it down. And you guys are smart people. You've already been really working with proofs and you really haven't even known it yet. Okay? So we'll get through chapter 2 together. No worries. I'm not worried. Okay? Let's get started. Let's get started with 2.1. We're talking about conditional statements. What's a conditional statement? A conditional statement can be written in if-then form. So it's really our if-then statement. They break it down into P and then Q. Okay, that's just saying if P, then Q. So if something, then something else. They give an example here. If a polygon is a triangle, okay, so think if a polygon is a triangle, so we're talking about a triangle, then the sum of its angle measures is 180 degrees. And we know that's true, right? We know that the sum of the angle measures of a triangle is 180 degrees. So here is our P. This statement here, that's P. So if P, then Q. And we'll break this down even more throughout this lesson. But that's really the basis. That's where we're starting here. A hypothesis can either be true or false. So think of a true hypothesis, think of a false hypothesis. The same is true of a conclusion, right? A conclusion can either be true or false. For a conditional statement to be true, the hypothesis and conclusion do not necessarily both have to be true. Okay, so that's good to know, that both of them do not have to be true for the statement to be true. We'll get through an example here in a second. Just below, we want to determine whether each conditional statement is true or false, and then justify our answer. So let's go to letter A here. If yesterday was Wednesday, okay, well, yesterday was Wednesday, then today is Thursday. Is that true or false? That has to be true, right? Thursday follows Wednesday every day of the week since the beginning of time. It's Wednesday, then Thursday. Okay, so if yesterday was Wednesday, then today is Thursday. That has to be true. If an angle is acute, so what does acute mean? Acute. Acute means less than 90 degrees. Right? Something is less than 90 degrees. Then it has an angle measure of 30 degrees. Is that true or false? This one's actually false. Why? Because we could have 45 degrees, we could have 70 degrees, right? Any degree that's less than 90 is an acute angle. So it's not necessarily always 30 degrees, right? So that's a false statement. Letter C. If a month has 30 days, then it is June. Okay, is the only month of 30 days June? No, that's false, right? Why is it? Because, well, think of another month with June. I think April, I know September, November? April, June, September, November, they all have 30 days, right? So it's not necessarily always June if the month has 30 days. Last one. If an even number is not divisible by 2, okay. So think about that. If an even number is not divisible by 2. Let me ask you this, what's the definition of an even number? I'm testing your brain here. What's the definition of an even number? The definition of an even number is that it is divisible by 2. So even number is always divisible by 2. Okay? Don't write true or false yet. The statement is not yet false. Okay? Then 9 is a perfect cube. Then 9 is a perfect cube. What are perfect cubes? Perfect cubes are a number that is multiplied by itself 3 times, goes into that number. For example, 8 is a perfect cube. Why? Because 2 times 2 times 2 is 8. Okay, well, what's 3 times 3 times 3? That's 27. So 9 is not a perfect cube. So 9 is not a perfect cube. Okay. Here's where it gets kind of tricky. This is really kind of confusing, mostly because we don't really work with false hypotheses and false conclusions together, right? But this is actually a true statement. Okay? We have 2 false. So if your hypothesis and conclusion are both false, then this is a true statement. Okay, so let's go through this. Let's go through P and Q quick. If yesterday was Wednesday, that's P. Then today is Thursday, that's Q. And we had true and true. And it ended up being true. This one down here, if an angle is acute, that's P. Then it has a measure of 30 degrees. Okay? That was kind of false, right? We had true and then false. And it led to a false statement. Same with this one. It had true, month has 30 days and it is June. That was false, right? Because it can be multiple months. This one, if an even number is not divisible by 2, that was false. Then 9 is a perfect cube, that was false. And we led to a true statement. And this might help us out in the long run. Let's move on. All we want to do is use the points in the coordinate plane to determine whether each statement is true or false, and then justify. Okay, triangle ABC is a right triangle. Let's draw our triangle ABC. Goes A, B, C. Is that a right triangle? Yes, it is. Why? Because AB is vertical. BC is horizontal. Okay, which means they are perpendicular. So these are perpendicular. I'm just going to say perpendicular. And perpendicular means that ABC, angle ABC, is a right angle. Okay, you can justify it any way you want. This is my way, saying that those 2 segments are perpendicular, so they form a right angle, which means that triangle is a right triangle. That's a true statement. Okay, same thing down here. Oh, I forgot to erase some parts. That's okay. Okay. I don't know what I just clicked there. There we go. All right. BBC is an equilateral triangle. Let's look at it. BBC. So this triangle here. What's equilateral mean? Equilateral triangle means that all sides are equal, right? That's an equilateral triangle. Are all sides equal in length? Well, we kind of have to do a little math here. We have to think how long is each segment? Well, we know that BC, we can count that one. That's 3, 4, 5, 6, 7, 8. Okay. We need these 2 other sides to be 8. I'm going to use a distance formula here. We have a point at 0, 5. Then we have a point at -4, 0. Okay, distance formula. I'm going to take -4 minus 0, square it, plus 0 minus 5 and square it. So I have 16 plus 25. What's the square root of 16 plus 25? I have to do a little math here. 16 plus 25 is 41. And the square root of 41 is just over 6, like 6.4. That's me in my head guessing 6.4 around there. But it's not 8, right? Those do not equal each other. So this B is false. All right. Letter C. BBC is an isosceles triangle. So same triangle. Is an isosceles triangle. Well, two sides have to be equal in length, right? Well, let's count this one. We know it goes up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Up 5 over 4. How about DC? Does it have the same slope? 1, 2, 3, 4, 5. 1, 2, 3, 4. Yes. So yes, this is an isosceles triangle. Two sides equal, and it is BD and DC. Quadrilateral ABCD. So now we're talking all these points. This quadrilateral here is a trapezoid. What's the definition of a trapezoid? It has two sets of parallel sides, right? We know that this side and this side are parallel. So they're both horizontal, so that's true. Okay. Is that same figure a parallelogram? What's the definition of a parallelogram? You might have to look that up. The definition of a parallelogram is two sets of parallel sides. And AB is vertical. This is a vertical line. And DC is a kind of at an angle. Those are not parallel. So this is false. Moving on. Exploration 3 here. Determine whether each conditional statement is true or false. Justify your answer. Okay, so conditional statement, we're going if P, then Q. If triangle ADC is a right triangle, then the Pythagorean theorem is valid for triangle ADC. Is that true or false? That's true. Why? Because the Pythagorean theorem is always valid for, not ADC, but for all right triangles. The Pythagorean theorem is always valid for all right triangles. Okay, that's true. Letter B. If angle A and angle B are complementary, go back to chapter 1. What does complementary mean? It means they add up to 90 degrees, right? Then there's some of the measures is 180 degrees. Ooh, nope, that's false. That's false. Complementary means 90 degrees. Okay, so that's false. Letter C, if figure ABCD is a quadrilateral. Okay, quadrilateral. What does quadrilateral mean? It has four sides, four angles. Right? Then the sum of its measures is 180. No. Quadrilateral, that's 360. No, that's false. Letter D, if points A, B, C are collinear, then they lie on the same line. What's the definition of collinear? Same line, right? Collinear, same line? True. If line A, B, and line B, D intersect at a point. Okay, so there's A, B, B, and then here comes C, D. Oh, sorry, B. Oop, I drew that wrong. Restart. My bad. A, B. Okay, and BD, so they go through at B. And do they form two pairs of vertical angles? Well, we have a vertical angle here, vertical angle here, we have vertical angle here, and vertical angle here, right? That is true. When a conditional statement is true or false, okay, we want to communicate our answer. So, when is a conditional statement true or false? Sorry, I read that wrong first. A conditional statement is only false. So, a conditional statement only false when a true hypothesis produces a false conclusion. Okay, that's the only time a conditional statement is false. Okay, so if I have a true hypothesis, okay, and a true conclusion, it's going to be true. If I have a false hypothesis and true conclusion, it's true. When I have a false hypothesis, false conclusion, it's true. When I have a true hypothesis and a false conclusion, it's going to be false. Okay, moving on. Number 5, write one true conditional statement and one false conditional statement that are different from those. Okay, so let's just come up with an example. Let's write a true conditional statement. And let's come up with something in school. Okay. A true one. How about this? If you are in geometry, then you are in math. Is that true or false? That's true, right? Geometry is math. So if you're in geometry, then you're in math. That's true. Let me try another one. Let me come up with a false one. A false one would be if you are in if you are in the school. Okay, let's pretend that everything is back to normal. You're in school right now. Let's pretend that. If you're in the school, then you are in gym class. Right? Is that always true? No. No, because you could be in my class, right? Depending on the hour, depending on the grade. Okay, so that one is false. Let's move on. Excuse me. Here we have a bunch of definitions. Okay, first one, conditional statement. Conditional statement is, I'm going to write these in my own words. Hypothesis, then conclusion. Okay, and I'm going to say P, Q. If P, then Q. If P, then Q. If then form. If hypothesis, so P, then conclusion, Q. Okay, so if something, then something. Hypothesis. The if part. That's really, I'm really breaking these down. If part. That's our hypothesis. Conclusion is the then part. Okay, these are my own words. You can write these down in your own words if you'd like, but this is what I am writing. Negation. Negation. This is important to remember. Negation is the opposite. Okay? Of the original. Okay? An example of this would be, I'm going to write it in blue here. If I go to the park. Okay, there's my original. If I go to the park. My negation would be if I don't go to the park. That's my negation, the opposite of the original, if I don't go to the park. Okay? The converse is opposite the conditional. We just exchange the hypothesis and the conclusion. So an example would be, if Q, then P. That's our converse. If Q, then P. So it's conclusion, then hypothesis. The inverse is the opposite, or the negation, hypothesis, then opposite, conclusion. Okay. The contrapositive flips that. It's opposite conclusion. Opposite hypothesis. Okay. Now we'll go through those in the near future with you guys. And we'll have plenty more examples of those. Equivalent statements. When two statements are both true or both false. So two statements. Oh, wow, I don't know what happened there. Are both true or false. They are equivalent statements. Perpendicular lines. Perpendicular lines means that they create a 90 degrees. Those are perpendicular lines. Okay, they intersect at 90 degrees. Biconditional statement. It contains a phrase if and only if. So it goes P if and only if Q. Right? So I will go to the park if and only if it is sunny. That is a biconditional statement. Okay. Truth value and truth table are something that we're not going to go through in this class. Okay, so I'm not going to go through those two definitions. I'm going to move on to our extra practice here. First, here's our conditional statement, right? Here's our negation. Here's how we write not, or our negation, our opposite. Not P, our symbol is this. I'm going to write it a little bigger for you to see. That is the negation, or not P. Here's these written in words, very useful, right? Here's our converse, our inverse. Down here, contrapositive. And down here, our biconditional. Very important information that you should probably read over. Here we go. We're going to write the conditional statements in if-then form. So here, number one, we have 13x minus 5 equals negative 18 because x equals negative 1. How do we write that in if-then form? Because it says because x equals negative 1, that's our if. If x equals negative 1, then (13x minus 5 equals 15). That is our if-then form. The sum of the measures of an interior angle of a triangle is 180 degrees. Okay. So, how do we write this? If it is a triangle, then what? Then the sum of the measures of the interior angles is 180 degrees. Almost done. I know it's a longer video. I apologize. We are almost done. Let P be quadrilateral ABCD. It's a rectangle. And let Q be the sum of the angle measures is 360 degrees. Write a conditional statement. P then Q. The converse Q then P. The inverse and the contrapositive in words. Okay. Then we're going to decide whether each statement is true or false. This might take a second. Sorry. Okay. So here's a P. Here's Q. Let's write this. If, here's our conditional statement. Okay, we're starting right here. If quadrilateral, let's write that. If quadrilateral ABCD is a rectangle, then the sum of the angle measures is 360 degrees. Okay, is that true? If quadrilateral ABCD is a rectangle, then the sum of the angle measures is 360 degrees. Is that true or false? That's true, right? All quadrilaterals have an interior measure of 360 degrees. Okay, now, that was our conditional statement. We have 3 more to go. The converse is Q then P. So here's our converse. If, all we do is take our conditional, then our hypothesis. So if the sum of the angle measure is 360 degrees, then in quadrilateral ABCD is a rectangle. Is that true or false? You should say false. Why? Because the sum of the angle measures 360 degrees. That's every quadrilateral. This is saying that the quadrilateral ABCD is a rectangle based on that information. That's false, right? All quadrilaterals have 360 degree angle measures. Okay, next one. Next one is our inverse. So we just did the converse. Now we're doing the inverse. The inverse. Opposite P, then opposite Q. So, if quadrilateral ABCD is a rectangle, then, oh, sorry, back up. We have to do the opposite, right? Is not a rectangle, then the sum of the angle measures is not 360 degrees. If quadrilateral ABCD is not a rectangle, then the sum of the angle measures is not 360 degrees. That's false. Tell me why that's false in your head. Okay, it's false because quadrilateral ABCD, it's saying it's not a rectangle. But the angle measures of any quadrilateral is 360 degrees, right? So this is false. The contrapositive is not Q, then not P. So if the sum of the angle measures is not 360 degrees, then ABCD is not a rectangle. True or false? If the sum of the angle measures is not 360 degrees, then quadrilateral ABCD is not a rectangle. True or false? I want you to think about this one. Okay. If the sum of the angle measures is not 360 degrees, then the quadrilateral ABCD is not a rectangle. That one is actually true. Right? Because if the sum of the angle measures is not 360 degrees, and this is not a rectangle, it can be. Sorry, let me think about this. The sum of the angle measures is not 360. Right. If it's not 360 degrees, then the quadrilateral is not a rectangle. That makes sense, right? If it's not 360 degrees, it can't be a rectangle. Okay, so that is true. These last four are something you could try on your own and work out on your own.